So far what did we discuss in the first 2 days? First 2 days in the sense in my 2 sessions. We have discussed about the basic machine learning concepts and we have seen how do we develop a machine learning algorithm, right? Are you all okay with that? Okay, what did we do in second class? We have seen concepts of deep learning and we have seen how do we develop a basic deep learning model using the libraries, and we've also seen how the internal operation of a neural network works, and we have seen how do we develop ANN from scratch. Did you all work on the exercise yesterday? Okay. So today we'll be talking about recurrent neural networks. Okay. So in the last session we have seen what are neural networks and different types of neural networks. So how many types of neural networks we have? Three. What are they? ANN, CNN, RNN. What are ANNs? Artificial neural network. CNN, convolutional neural network. RNN, recurrent neural network. So we've already seen and we know how do we develop ANN models, right? So as told you, CNNs are not part of this semester syllabus, okay? So you can just refer to the videos if you are interested into that, okay? So in this program for the second semester, you'll be entirely dealing with working on which type of neural networks? Recurrent neural networks, and we have advanced recurrent neural networks which are in short called as large language models. Taking these neural networks as base, we have all other advanced large language models developed like transformers. So in this semester you will be learning about what RNNs are and what are the other types of RNN variants or other types of large language models which are developed with RNN as base. So today's class would be most important or the basic introduction to the entire semester course that we are going to do in these 3 weeks. Is it clear? So if you have a konjam complicated, when I say it is important, obviously it will be little complicated. Understand, as we are moving forward towards LLMs or generative AI, the complexity increases. Anni machine learning laga, deep learning laga easy ga undavu. So you just have to cope up with how do we advance in learning. Okay. So if you find it difficult understanding or if you have any doubts at any point of time, please raise your hands. I'll repeat that topic again or I'll explain it in more detail. Okay. So as seen earlier, we were talking about 3 different neural networks in which we were talking about ANN. When do we use ANN? When do we use CNN? When do we use RNN? When you have numerical data, we have 4 different, before this we have discussed about 4 different types of data that we usually handle. What are they? Numerical data. Give me an example of numerical data.
Stock.
Weather prediction, stock price prediction, pass or fail, and all that comes under numerical data, right? Second type of data? Text data. Okay. When I talk about text, it is natural language. Okay. Not just our local languages, but all the languages around the world. Third type of data? Voice data. Again, this is also a language data. Okay. Voice in the sense we speak in some language. Okay. And then fourth type of data? Image data. Right. So we usually handle with numerical data, text data, image data, and voice data. So when we talk about ANNs work well with which type of data? Numerical data. ANNs can work with all types of data, but we have some limitations. So hence we restrict using ANN only for what? Numerical data. Okay. So what was the example that we have seen in the class on ANN model? XOR gate, a simple XOR gate, numerical values. What was the exercise that you have done in the practical session? Churn modeling. What do you mean by churn modeling?
Exit.
Checking if a person will exit or continue with the bank or credit card or whatever it is. Okay. So that is a classification task again. Okay. So where we deal with what? Numerical data. What is his bank balance and all that. Depending on that, we'll know whether a person will continue or exit the bank. Right. So ANNs can work well with what? Numerical data, but they have own limitations when they work with other data. That is what is that? We'll see. Okay. And then we have seen with which type of data? Second type of neural network? CNN. CNN works well with what? Image data. That is also why we'll see in brief. Okay. And then we have seen what? RNN, which works with what? Text data. So what is that text data? What is that sequential data is what we will see today in the class. Okay. So these are the contents that we are going to cover today in the class. So we'll see what are neural networks, brief overview or limitations of ANN, CNN and RNN. So today in the session I would like to focus much about what are RNNs, how RNN works, different types of RNN, how data is processed in RNNs, what are different applications, advantages, disadvantages, and simple exercise on RNN. Okay. So when we talk about deep learning, what is deep learning? It's a subset of machine learning. What is machine learning? The subset of AI. Okay. So when I talk about deep learning, first thing is it is subset of AI. But what does it have? It has neural networks which will do what? Deep understanding of data, or it analyzes the data in depth and produce the predictions accurately compared to what? The basic machine learning models. Okay. Now what are neural networks? Neural networks are nothing but interconnected layer of what? Some nodes which are called as neurons. So what are the three different layers that we have when we talk about neural networks? Input layer, hidden layer, and output layer. How many input layers? One. How many hidden layers? Depends upon the data that we take, depend upon the accuracy that we want. More processing may help in, not 100%, may help in increasing the accuracy. That again depends on other parameters as well as the quality or quantity of data that we take. Okay. Three different types of neural networks. What are they? ANN, CNN, and RNN. Okay. Now, as you can see on the right hand side, you can see ANN, CNN, RNN are basic types of neural networks. On the left hand side, you see transformers and other types of neural networks. Other types of neural networks are advanced models which are taken from base of what? These three neural networks, which are ANN, CNN, and RNN. Okay. So what are ANNs? ANNs are the computational models which are derived by what? The neural networks, which will have the exact replication of how human brain works. Okay. So ANN consists of layers, and we add what? Bias and weights to that, such that we'll try to get good accuracy by reducing the loss. Okay. Now these are some challenges of ANN. Okay. Let me discuss each and every challenge in detail. So when we talk about image processing with ANN, let's talk about what? Image processing with ANN. What is the image that I've taken there? A cat image. What is the size of the image? How is the image represented? Pixels. That is, I have rows and columns. Okay. Number of rows, number of columns. Rows into columns will give you number of pixels which are there in that particular image. Pixel and a dot. All these dots connected will give you an entire image. Okay. Now when you look into that, what is the size of the image? 224 by 224. And the small image adi. 220 real ga aithe manaki 1024 or more than that untadi image size. Okay. So for 224 by 224, total pixels are 6,02,112. So how many input neurons you want in the input layer? 6 lakhs neurons only for processing one image which is of very small size. If I give you a very big image of 1024 by 1024 and I'll give you 1 million such images to process, can your ANN work, or will your ANN work? It will work, but what will happen? The model complexity will be increased, the loss we are not sure about it, and processing images, all this would be very difficult because of this one particular point. So we don't use ANN for what? Images. This is one drawback of ANN. Okay. Second, when I talk about text data, okay, so you see two figures. What is the input in the first text data? How are you? How many words are there? 3 words. So I have to give these 3 words to 3 different neurons. Now this is one architecture. But when I talk about me talking to you, do I say ask only how are you? Man chala maatladtanu. Ippudu na class undi. For example, my today's class. How many words do I speak in today's class? Many words, in thousands, right? So imagine these 1,000 words given as input to neuron again. And does machine understand your language or these words? It understands only numbers. So you have to convert these language into what? Some embeddings, word embeddings, which we'll discuss in the next session. Okay. So the language will not be given directly. The language should be converted to some word embeddings, which are some numbers, and they should be given to what? The neurons. Okay. The problem here is, in the first case I have 3 words. In the second case I have 4 words. So if my length of the words are changed, I have to change the architecture only. Yes or no? Because in the first neuron, the first artificial neural network, I have only 3 words. In the second case, I'm talking about what? 4 words. Now let's take, I will give you a paragraph with 5 sentences. I'll give you a paragraph with 5 sentences. So does all the sentences have equal number of words? So let's say, I am Asha. I had my breakfast today. Okay, I am working in KMIT from 2009. Okay, so my age is this much. I work in this department and all that. So are all the words same in every sentence of this? So when I process sentences, for every sentence I have to change my neural network, because for every sentence I have different number of words. For every sentence the length of the input layer will change. So will your artificial neural networks work for text data? No. Why? This is the reason. Okay. Fixed number of neurons will not work, because every time I process a text, I process sentences, and each sentences will have what? Different number of words. Okay. Next. As I told you, how are you should be decoded into binary language. Okay. So we use label encoding or we use one hot encoding. Okay. So how are you ante 3 words unnai kabatti I'll decode into 3 bits. 001 it is how, 010 it is are, 100 it is what? You. 3 words kitla. How many words do I speak in the class today? Some thousands of words. Appudu em cheyali? Okka word ni represent cheyadaniki I have to use what? Those 1000 words where only one bit would be high, the remaining bit would be 0. Second word, also same 1000 words where only one bit would be high, the remaining bits would be 0. So in this way, too much computation for converting every word also happens when I take what? Artificial neural networks for processing my text data. Okay, second thing. What is the sentence that I have? I ate Golgappa on Sunday. Okay, so what is the translation output that I have? Ravivar ko maine Golgappa kaaye. So this translation is perfect. Okay, now I'll change the sentence. I'll change the sentence to, on Sunday I ate Golgappa. Even this is correct, right? I ate Golgappa on Sunday is also okay. On Sunday I ate Golgappa is also okay. But when you take that Hindi respective conversion, the meaning would be different when I take the sentence in different way. So no parameters are shared when I talk about using ANNs for processing which data? Text data. Okay. Since we see that ANNs work well with what? The numerical data only. For images, text or voice, ANNs badly fails because of its own limitations. So hence we go for second type of neural networks, which are called as what? Convolutional neural networks. Of course, we will not explain or study this in detail, but I'll explain you briefly what is this. Okay. So what is the difference between ANN architecture and this architecture that you see? ఇక్కడ కూడా image input తీసుకున్నాను. I have some operations in between, and then again I have my ANN network only. Again I have my ANN network only. So convolutional neural networks work in this way. They take the data. Okay. So before this data is given to ANN, which we call it as fully connected network. Can you see that fully connected layer at the bottom on the right hand side? Okay, so that is ANN. Fully connected layer is nothing but ANN. So before we actually give the input data directly to ANN, we perform 2 operations here. How many operations? 2. First one is called as convolution operation. Second one is called as pooling operation. What are they? Convolution and pooling. Okay. Now what are the drawbacks of ANN when we deal with images? Rendu cheppa. Number of neurons are more and identifying features is difficult. Okay, I'll tell you what. If suppose I am standing here and Kalyan takes my picture. Okay, so it is easy to identify ASHA in this picture because ASHA is standing. You're all sitting. Clear ga kanipistundi kabatti identification is easy. If I sit amongst you, ఆ మధ్యలో ఎక్కడో కూర్చున్నాను అండ్ క్లిక్ పిక్చర్ లైక్ దిస్ అండ్ సే ఐడెంటిఫై ఆశా. ఈజ్ దట్ ఈజీ ఆర్ ఈజ్ దిస్ ఈజీ? దిస్ ఈజ్ ఈజీ. సో దీనికి ఏఎన్ఎన్ సింపుల్గా వాడుకోవచ్చు. కానీ వెన్ ఐ టాక్ అబౌట్ దాట్ ఐ నీడ్ మోర్ ఫీచర్ ఎక్స్ట్రాక్షన్. I need more feature extraction to be done. Yes or no? So this convolution operation will help us understanding the in-depth of the image such that the feature extraction would be done very clearly. Is it clear everybody? And next pooling layer will reduce the size of the image. The big size of the image was the problem, right, for processing ANNs. So here pooling layer will reduce what? The size of the image. Is that clear? So in convolution, we apply some filters such that the feature extraction would be done properly, which ANN was failing. And using using pooling layers, we reduce the dimensions of the image. Now I am all set. These were the two drawbacks of ANN handling images. Hence, I have added two layers before what? The network. And I call those layers as what? Convolutional layers and pooling layers. Okay. Now, third problem is, how is the image represented? In 2D array. What do you mean by 2D array? Rows and columns. But ANN has 1D array because the elements are given in which order? In one column. X1 to X784 if I have 28 by 28 size image. Yes or no? I have one column when I talk about ANN. But image has what? Rows and columns. So I have to convert this 2D into 1D vector by a process called flattening. By a process called what? Flattening. So in CNN what we do is, listen to this point very carefully. We take the image of size n by n. We apply that to convolution. We apply that to pooling. It is pair. So you can add n number of convolution layers, you can add n number of pooling layers. Same akkada hidden layers laga, you can add what? N number of convolution. Atlane CP cheyoddu. CP in pairs. Convolution pooling. Malli dan tarvata convolution pooling. Atla if you want to reduce more size or if you want to extract more good features, you have to add more number of convolution layers and pooling layers. Okay. Now understand. Now see the diagram. What is the image that I have taken? Tweety. Okay. So I am giving that to what? Convolution layer. Some part of feature extraction would be done. After that, what do? I give it to pooling where the size would be reduced. I'm still not happy. So again, I'll go for what? Convolution. Feature extraction in depth. Again, I'll apply that to what? Pooling. Now I am okay. After that, what I do? Before I give that to the ANN, I want this 2D image to convert to what? Flattening. So I apply flattening layer and then I apply it to input layer, hidden layer, output layer where I do my classification. Okay. So I generate my output saying whether it is Tweety, whether it is Goofy, whether it is Donut. So what is the probability is good for which output? Tweety, it is 0.7. Hence the image classification has been done properly. Is that clear everybody? So this is all about convolution. What is the difference between ANN architecture and CNN architecture? In ANN we have input layer, hidden layers, output layer. In CNN we have n convolutional layers followed by n pooling layers, one flattened layer and then fully connected layer. Is that clear everybody? Okay. Convolution layer, pooling layer, fully connected layer. We also have flattening layer which I missed to put in there. Okay. So what are the advantages of CNN? It can automatically extract the features. Why? Why is that able to extract the features? Because we have convolution operation. Okay. Now when I talk about challenges of CNN, even CNN have some drawbacks. Like how we have seen the drawbacks of ANN, even CNN have some drawbacks. So when we talk about the drawbacks of CNN, the first one is difficulty in dealing with variance in the data represented. That means, does everybody click the pictures in the same angle and very neatly? Okay. That is one point. Second point, the clarity of the images is also different depending on the cameras that we use. Sometimes we may get blurry images. Sometimes we will be given only shadow images. Sometimes we will be given only the face part hiding. I hide behind a wall and I just peep through it. Only some part of my, half part of my face would be given. So we have different types of variations of data that we have. So handling these different types of data is again a complicated task for what? See, correctగా మొత్తం ఇమేజ్ ఇస్తే బాగుంటుంది కానీ ఇట్లా డిఫరెంట్ వర్జన్స్లో డిఫరెంట్ ఎక్స్పెరిమెంట్స్ చేస్తే పాపం CNN will also fail because it is not a human at the end of the day. Okay. So it is just a machine learning model which will get trained and understand only if you give the data properly. అట్లా మీరు different జిమ్మిక్లు చేసి డేటా ఇస్తే it will not understand. Okay. Animations చేసి అట్లాంటివి ఏవి చేసినా it will fail. So this is different types of variations of data. Second, computationally demanding. So CNNs ante deals with images. As I said, ఒక్క image కి అంత కావాలి. If I process some 1 million images, obviously what will happen? Computational cost would be more. So normally CPUs మీద GPUs మీద వర్క్ అవ్వవు. You require TPUs and higher processing units for working on with what? Real-time data where you deal with CNNs. Okay. So hence we say computationally demanding. Okay. So basically the conclusion is what? ANNs are used for complex problem which have numerical data. CNNs are used for dealing with what? Image processing tasks. RNNs are used for what? Natural language data or sequential data. Okay. Now let's get back to what are RNNs, how do they work and all that. The main topic of today's session. Okay. Now, when I talk about sequential data, okay, as told you earlier, sequential data is again numerical sequential, text sequential, sometimes image sequential. When I talk about image sequentials, the grid image, if I divide the image into grids, ఇప్పుడు Instagram లో కొత్త ఫీచర్ వచ్చింది కదా 9 boxes వచ్చి ఆ ఇమేజ్ జనరేట్ అవ్వడం. If that one box or other box changes, the entire image will have different meaning. Yes or no? So here the sequence has to be followed in the image. Okay. Other than sequence image, what do we have? The text also can be in sequence. When I talk about text as in sequence, what do you mean by that? The language that we speak. Okay. If I say I am Asha, you will be able to understand. But if I say Asha am I, will you understand that? మీరు మనుషులు మీకు అర్థమవుతుంది, you'll understand that she is wrong. But machine will not understand. Okay. Machine will think that is correct sentence and give you the predictions as per that. Okay. So when I talk about natural language, there are so many underlying things that you have to consider when we talk about natural language. Okay. Grammar should be correct. Parts of speech should be there properly. Semantics, syntactics, everything should be aligned properly for natural language to be processed. Andukane we go for text pre-processing steps which you will be taught in the next class. Okay. For now just understand that when I talk about sequential RNN and sequential data. Okay. So when I talk about sequential data, we may have numerical sequential data, image sequential data, text sequential data. All types of data would be in sequential. Okay. Now when I talk about numerical sequential data, I have weather prediction and stock price prediction. If I say, let's take one company, Google stock price anukundam. Okay. How will you predict the Google stock price for tomorrow? In general, by looking today's data or by looking at tomorrow's or past 1 week or past 1 month. Yes or no? So is it okay if I predict tomorrow's Google stock price based on 1980's Google stock price? So I want which type of data? Previous data, that too in sequence. Okay. Why am I calling it as sequence? I can't take one data from 1987. I can't take one data from 1990. Atla ippudu randomly I can't take. If I want to have proper predictions with good accuracy, what do I have to take? I have to look at previous data sequentially. Okay. Similarly, when I talk about weather prediction, if I want to predict tomorrow's weather, I look at what? Today's weather, yesterday's weather, or day before yesterday, or past 1 month, or past 2 months or 3 months of winter season. But is it okay if I check summer's data and predict tomorrow's weather? So I want what type of data here? Sequential data referring to the past. Okay. Now when you have seen ANN, how did you process the data? From input to output in forward propagation. ఇక్కడ కూడా బ్యాక్వర్డ్ ప్రాపగేషన్ చేసినాం, కానీ డేటా ఈజ్ నాట్ ప్రాసెస్డ్ ఇన్ బ్యాక్వర్డ్ ప్రాపగేషన్. వీఆర్ ఓన్లీ అడ్జస్టింగ్ ద వెయిట్స్ బట్ ప్రాసెసింగ్ ద డేటా ఓన్లీ ఇన్ ఫార్వర్డ్ వే, దట్ ఈస్ ఫ్రమ్ ఇన్పుట్ టు అవుట్పుట్. బట్ ఇన్ కేస్ ఆఫ్ RNN, when I talk about RNN, I have to understand what? Previous data. I have to go front and I also have to go back. And the previous data should be stored. 2 points. When I talk about ANN and CNN, we process the data only in forward direction. That is from input, we process the data and we generate the output. But in case of RNN, I also have to look at the previous data. Once I process something, if I am missing something, I have to come back. For example, when I talk about text pre-processing, let me give you a sentence. I am Asha, I am dash in auditorium. Fill that word. I am teaching in auditorium. Okay. Now first I process I am Asha. A dash వచ్చినప్పుడు what do? I have to refer what is there previously. I also have to refer what is there ahead of it. Okay, yes or no? In the auditorium and ledanko, I may have what? I dance, I learn, I sing, I sleep అట్లా చాలా వస్తాయి. Yes or no? Again when I say auditorium అంటే డాన్స్ కూడా చేస్తారు కాబట్టి so again I have to refer the next sentence. What is that next sentence? I am Asha, I am dash in the auditorium, my students are listening. So when I say my students are listening, it means that she is teaching. If I stop there where I am Asha, I am dash in the auditorium ante probability of teaching may be 60, probability of dancing may be 40, probability of sleeping may be 0 or 1. Is it clear? So when I am talking about processing a sentence or text, I also need to store what? Previous data, and I also have to look at what? The data ahead, and based on that I have to pre-process. So here the data processing will happen in forward and reverse, where if I want to process the data in reverse, I have to store the previous data. Is it clear? So for that we say RNNs have small memory elements. Small memo. Our memory element ekkada untadante hidden states lo untayi. Where do we have the memory elements? In the hidden states. Okay. Now let's look at the architecture. First read that what is RNN. RNN comes into picture when there is a need for predictions using what? Sequential data. Sequential data can be a sequence of numbers. I forgot to put numbers there. Sequence of what? Numbers, image or text data. Okay. Now look at the architecture. Okay. Now let's see. I'll explain the architecture later. So what is this now? Read the second definition for RNNs. RNNs are what? A class of neural networks that are powerful for handling what? Sequence data such as time series or natural language. Read that last point, which is very important. RNNs are designed for sequential data. We know this. Ahead of that, what is that? Each neuron connects to the next layer and to neurons within the same layer. What do you mean by this? In the previous case, when we have seen RNN, ANNs and CNNs, how was the connection between neurons or layers? Input layer was connected to hidden, hidden was connected to output. But did you observe hidden being connected to hidden? But here what is he saying? In RNN networks, the neurons are connected from what? One layer to other layer, and also within the same layer or within the same neuron. When I say within the same neuron, which means that what? It is having a feedback. It is having a feedback. So in this feedback, we store the data. Using this feedback link, we store the data. Okay. Like ANN and CNN, RNN also learns from the data, but here the data is in which order? Sequential order. Okay. From there on, it doesn't process the data on the inputted data alone, but it uses data from past inputs to make the decisions, not just on present data, but also on what? The past data to make the predictions. Okay. In a nutshell, this architecture is built for having a memory. A feedback element, feedback connection works as what? A memory element. Okay. Can you see this, guys? So what is happening? I am not just connecting from one layer to another layer. I am also going back. Okay. What should we use RNN for? Where do we use RNN? For all the natural language processing tasks like machine translation, sentiment. What is sentiment analysis? Give a review and ask whether the review is positive or negative. Okay. Machine translation, we know, language translation task. And then speech processing, time series forecasting. Okay. Another good example of time series forecasting is ECG signal. Okay. ECG తీస్తారు కదా heart ki. Appudu you get ECG signals, right? So even they are what? In sequence. A sequence batte they'll predict whether your ECG is normal or abnormal. Yes or no? So time series forecasting is processing the signal at some particular time. Okay. And then music generation. Music kuda oka paata ardham kavali, oka paata meaningful ga undalante it should be in some order. Which ga unte that is called not proper music. Yes or no? Video analysis. We get subtitles, right? Subtitles for a movie generation. Nobody will sit and manually do it. It is also an AI task. Okay. So again that will be processed in what? Sequence. Language, video to language translation. So all these are different applications of what? RNN. Okay. Now what does RNN do? RNN will do auto translation, Auto completion, not interested at is the input. So what is the output that is translated? Not interested at this time is this time is the prediction. Next, translation, how are you? Okay, that is also translated. Next, NER. NER is all about identifying the entities in the given sentence. When I say I am Asha, I am working in KMIT. Here the entities are ASHA, which is a name, KMIT, which is a organization. KMIT was established in 2007. So 2007 is the year. So the entities, the main entities in the sentence would be recognized. For this also we have to process. So this is one application of what? RNN. And then we have sentiment analysis. What is sentiment analysis? Giving a review and checking whether it is a 1-star review, 2-star review, or whether it is a positive review, negative review, and so on. Okay. Now, the second again example of RNN is, what do you observe here in this data? There are 2 columns. Okay, what do I have in first column? Days. What do I have in second column? The cuisine. Okay, so how many days are there? 7 days, Monday to Saturday. How many different cuisines are represented here? 4. What are they? Japanese, Chinese, Thai, and Indian. So it means I will eat Japanese on when? Sunday. Chinese on Mondays. Thai on Tuesday. Indian on Wednesday. And I repeat them again. So this is sequence data. I am processing them in sequence. But the problem here is, look at that. So on which days am I eating Thai food? Am I eating Thai food every Wednesday? Thai food is getting changed. Why? Because the number of days are 7. The number of cuisines are only 4. So when I repeat this data in sequence, obviously I can't predict my output here based on input. Okay, can I ask you if I am eating Thai only on Wednesday? I am not predicting my output based on the inputs here. But what am I doing? I am predicting the outputs based on the sequence in the output itself. Are you getting my output? So based on previous output, I am predicting my what? Next output. That is, I don't eat Thai on every Wednesday, but I eat Thai food after I eat Chinese food. That is, I want to understand my data in sequence on the previous output, on input also, and also upon the previous state output. Okay, now this is the working principle of RNN. Okay, so as you can observe here, X is what? The input layer. H is what? The hidden layer. Y is what? The output layer. So what do you observe the difference? What is the difference that you see here? The hidden layer has what? A feedback loop, such that it will store the previous words and it will process the sentence in sequence. This is one advantage. Second advantage, are you able to see only one block of that, or do you see some n number of hidden layers here? Only one block. That is, RNN structures are basically unrolled. Okay, that is, they are available in only one block. Depending on the input that you give, they'll unroll into n number of sequences. Akkada neural networks, when we talk about ANN, based on input we take neurons, right? Yes or no? And if I change the number of words in the sentence, I have to change different. That was the problem, variable length sequences. But here, basically the diagram is available as fixed based on the sentences. First, I'll talk about I am Asha. I give this sentence. Then the unrolling happens where I'll get 3 hidden layers. Okay, in the second sentence, I take I am teaching today in the class. I have 5 words. So again, unrolling happens 5 times. Okay, and next I take what? Today I am covering RNN concepts for this particular batch. Again, if I have 10 words in this particular sequence, the unrolling happens 10 times. So initially we don't have fixed architecture. Based on what? The number of words in the input, unrolling happens and the sequence will process. Are you all clear with this? This is how it takes. Depending on the input data that you give, the unrolling thing happens. Is it clear? Yes or no? Input layer. What is Y? The output layer. What is H? The hidden layer which will have the what? Feedback loop. Okay. Now look at that. You see 3 hidden layers, right? Observe the one in between. The one in between is taking the original input. What is that input? X of t. x of t is what? Please understand. ఇది ఒక్కటి అర్థమైతే మొత్తం అర్థమవుతుంది. Okay, please listen to this. x of t, the input that I am taking. Okay, what is h of t? The hidden layer output that is generated. What is y of t? The final output. Now here, h of t is equal to, I say h of t is equal to x of t into h of t minus 1. What is that? H of t is equal to x of t, the current input, and the input from the previous state, which is stored where? In the hidden layer h of t minus 1. That is, if I give I am ASHA, first I process అయిపోతుంది, x of t would be what? I, that would be given to h of t. Now what does h of t has now? I. What does h of t has? I. Next I go for the second state. Now x of t would be where? In the second hidden layer. Here I give am word. Okay. Now how do I generate h of t now? I should add I and I should add am. Where is this am present? In x of t. Where is this I present? H of t minus 1. So what would be the current h of t? I and am. Where I is stored in h of t minus 1, am is stored in x of t. So I say h of t is equal to what? X of t into h of t minus 1. Are you all clear with this? That is, the current state output is equal to the present input and the previous hidden input. Write down that sentence. H of t is equal to, what is that? X of t into x of t into h of t minus 1. Are you all clear with this? Yes or no? Okay. Same like ANNs, we also have what? Input layer, hidden layer and output layer. Same like ANN, we should also add what? Weights and biases. Okay. Now rewrite the equation. Second kinda step lo rayandi. Look at that. H of t is equal to what? What am I writing? F of. What is this F again? Activation function. Okay. F of what? The weights. Wx into xt plus Wh into ht minus 1 plus bias term. Any doubt in this? What is W? The weights. Weights are added for what? Weights are added for input. Weights are also added for hidden. Okay. What is B? The bias term. Are you all okay with this equation? So what is h of t? The current state output, which is dependent on what? The previous state output and the current input. What is the current input? X of t, which is multiplied with what? W of x. Plus, what is the current state input? H of t minus 1, which is multiplied with WH as weight. Plus, finally, I add my bias term. Are you all clear with this equation? This ardhamaithe RNNs are easy. Okay. So, most probably, we will be using this function called as tan H. Which activation function in RNNs? Why? We will discuss later. Now, if you focus on that, you'll forget about the concept of RNN. Okay. Now, today, let's just understand how RNN works. Okay. As we use ReLU in the hidden layers of ANN, sigmoid and softmax in the output layers of ANN, we use ReLU in what? The hidden layers. Sorry. We use tan H in the hidden layers. Output again same. Sigmoid for what? Binary classification. Softmax for multi-class classification. No activation function for it. Output is always the same. Just note that in the input layers of RNN, we use which activation function? Tan H. Why? We'll see it in the next class. Don't worry about it. Okay. So what is that F that I am taking here? ReLU. So rewrite the formula again. H of t is equal to ReLU of then F is ReLU. Okay. The activation function ReLU. ReLU of same thing again. What is that same thing? xt into Wx plus ht minus 1 into Wh plus bias term. Clear everybody? How many of you have doubts till this? Please tell me if you have any doubts. Let me clear this now and then.
ReLU or tanh H?
For all the hidden layers, it is always tan H.
Just so you have to take H2 equals to ReLU of.
Sorry, tan H off, not ReLU off. Tan H off. Tan H off. For RNN, we use tan H. Okay. So what are these three diagrams? The first one is the folded diagram. Sorry. The first one is the unrolled diagram. The second one is called folded diagram. The third one is called internal hidden operation. What is happening internally in the hidden layer? It takes current input, previous input and generate the new hidden state. What is unrolling? When we deal with text data, we don't have variable length sequences. We have invariable length sequences. Hence, we take the folded diagram. Based on the input sequence, we unroll that. Is it clear, everybody? So, you have to understand these three diagrams. The folded diagram, the unrolled diagram, and inside one RNN unit, what happens? Is it clear? That RNN is nothing but the hidden layers. Okay? Now, what do we have in an RNN architecture? We have input sequence that we give. We also have what? Recurrent layer or the hidden layers. We also have output layer. We also have hidden state. State is nothing but the output of the hidden layers, hidden state. Okay? Now let's look at this. How ANN process the data. Okay? Read the first point. A single time step of the input sequence is provided to the sequence, which means one word would be given to one RNN layer. When I talk about I am ASHA, how many words are there in this? 3. So how many unfolded diagrams do I want? 3. So in the first RNN, which would be processed? I. In the second RNN, AM. In the third RNN, okay. Next, calculate hidden state. Okay. For the first hidden state, the previous hidden state is 0. So direct input would be given to output. But for the next word, the hidden state is calculated from previous hidden state and the current output. That is how we calculate the hidden states. And state transition. That means state transition in the sense, first where was my x of t? Near I. Okay. Now this I becomes I minus 1. When I process the second sentence, where is my x of t coming? In the second. First I take x of t in the first RNN, that is I. When I move forward, this x of t becomes xt minus 1 and x of t will be given to what? The next RNN. Input change aita undi kada. First I give I, this is x of t. Second I move my second layer where I give am. Appudu ikkada x of t, the previous one would be what? X of t minus 1. That is called as what? State transition. Next I have sequential processing. So in this way I process the data in what? Sequential order and try to generate the output. Okay. Now once I generate the output, again same thing. We calculate loss. We calculate what? Loss. How many types of loss functions did we see? Mean square error we used for what? Regression. Binary cross entropy for binary classification. Categorical cross entropy for multi-class. Same thing again here also. Same concept. After we calculate loss, if the loss is more, what do? Back propagation. Kani ikkada step by step ellali kabatti we call that as back propagation through time. For RNNs, same back propagation, but we call it as what? Back propagation through time, BPTT. So this is the process. So what do we do first? We give one input at each time step. That is, one RNN layer will have one word. One input at each time step. Second, we calculate the hidden states. We observe the state transition. After that, we process the data in sequential order. We generate the output by calculating the loss. And then if the loss is high, we again go for what? Backward propagation through time. This is how your RNN works. Okay. Now when I talk about advantages of RNN, okay, what is the first advantage? Sequence processing. Are your RNNs processing sequential data? Yes. Temporal dependency capture. Is your previous word also getting captured? Yes. Variable length input output. Is your RNNs able to take variable length input and output? Yes. Because we have what? Folded diagram which we will unroll based on the sequence length that we take. Next, compact representation. Okay, we have folder diagram based on that. So we say compact representation. Okay, versatility, context understanding. Because of the hidden state, I am understanding that ASHA is teaching based on what? The previous words or the next words. So context is being understood and the outputs are generated. Okay, and then shared weights. Shared weight in the sense, listen, I take only one network. I process first sequence, which is what? I am ASHA. Next, I have a paragraph in which I first process first sequence, which is ASHA. I am ASHA. And then say the second sentence is I am teaching in the auditorium. This is the second sentence. So even if you change n number of sentences, the weights and biases would be same, which will again reduce the complexity. I am not generating weights and biases again and again for different sentences. Why? The reason is I am ASHA sentence is totally different from what? I am teaching in auditorium. But in previous case, ANN lo, oka class data, the students are fixed. Yes or no? I can't change the students when I go for second propagation. I have to change the weights. Andukane prati time we process, we change the weights. But here in this case, I am using one RNN for one sentence. I am using the same RNN for another sentence, where first sentence is different from second sentence. So I need not change my weights every time I take a different input. Hence, the calculations or computational complexity is gradually reduced. Every time weights are changed, you have to calculate, we have to go for forward propagation, loss calculation and backward. So that is also avoided. So we call this concept as sharing weights. Okay, we'll see that once we go to the practical session. Okay, now let's look into different applications of RNN. What is the first application? Image captioning. What do you mean by image captioning? Give an image as input and output is what? The captions generated. So what is the caption that is generated? A dog catching the ball in mid-air. So why do I call this as a RNN task? Because the output that is generated is what? Sequential data or text data. Second application? NLP task like sentiment analysis. Okay, why am I calling sentiment analysis as RNN application? How do you give the sentiment or review? The text. Okay, as the data is processed as text, we call it as RNN application. Machine translation. What is machine translation? Converting data, text to data from one language to another, or voice from one language to another. So here the data is sequential. Here the data is sequential. Hence we call this as what? Application of RNN. Time series prediction. The data is again in sequential. Hence we call this as application of what? RNN. Okay. Now let's look into types of RNN architectures. We have 4 different types of RNN architectures. What are they? One-to-one, one-to-many, many-to-one, many-to-many. This one and many are input and output. So in the first case, how many inputs, how many outputs? One input, one output. How many types of neural networks? 4. One-to-one, one-to-many, many-to-one, many. See, the neural RNNs are complicated because when I talk about today's class, convert my today's class from English to Telugu. How many words do I speak in today's class? Many words. So converting all this would be very difficult. So you have to choose the architecture based on the application that you want. Okay. Now let's look into that. The basic one input, one output is called as vanilla RNN network. What is that called as? Vanilla RNN network. When I talk about one to many, what do you mean by one to many? Input is only one, outputs are many. For example, image captioning. In image captioning task, what is the input? Image. Only one image I am taking. What is the output that I am generating? Words, many words. So this is the example. Okay. So sentiment analysis. What is the input for the sentiment analysis? Sentence. The sentence has how many words? Many words. But the output is what? Positive review, negative review, neutral review, good, bad, or whatever it is. Okay, it will be only one. So many words are taken as input, but the output would be only one. So for this case, we go for what? Many to one. Language translation. Language translation. Today's class converted from English to Telugu. How many words I have in today's class? Many words. How many words would be converted into Telugu? Many words. So depending on the application that you work on, you choose different type of RNN architectures. Is that clear? Can I take one input, one output for language translation? Can I take many to many for output prediction, language, many-to-many for sentiment analysis? No, there's no need for so many outputs being generated when you want only one output. So depending on our application, we choose any of them for proper results. Okay, the same thing is being repeated. Now again, when you observe many-to-many, I have two different types of many-to-many, semi-sync and full sync. When I talk about NER, name entity recognition, I may have entity somewhere in between. Yes or no? I say I am ASHA, I am working in KMIT. So ASHA is an entity, KMIT is an entity. So this entity is available in the third place, that entity is available in somewhere else. So here I require full sync. But when I talk about what application, when I talk about semi-sync, give me an example of semi-sync. I take multiple series, weather forecasting of 3 days, and I want to predict for what? Next 3 days. 3 days use 3 days predict cheyanu. I'll take previous 3 days and I want to predict what? Next 3 days. So this previous 3 days, multiple inputs. Next 3 days is multiple inputs, but not simultaneously. I want it after these 3 days are ended, I want next 3 days. So that is how I take my semi-sync. RNN many-to-many semi-sync. Is that clear? So depending on the application, we choose different types of neural networks. Okay. Now RNNs also have problems. Like ANN and CNN, RNNs also have what? Problems. There are two main problems of RNNs. They are called as vanishing gradient, exploding gradients. What are the problems of RNN? Vanishing and exploding. Now listen to me, what is vanishing and exploding? When I talk about dealing with text data, okay, I'll give you a task saying develop a RNN model which will take one textbook as input. What is the input here? Textbook. And summarize the entire textbook into one page. What is the output here? One page. So this is called as text summarization. This example is called as what? Text summarization. That is, if you read the books, after every chapter we have summary, right? Yes or no? What is that summary? What did we study in this particular unit? Anedi summary laga 5-6 points ga istaru. Yes or no? So I want you to do that task. So is that an RNN task? Yes or no? Yes. Which type of architecture do I have to use for this? Many-to-many. Many-to-many obviously, because I have many inputs, many words in the input and many words in the output. Of course, the length of inputs in this and that may be different, but I have many inputs and many outputs. Are you all clear with this till this point? Yes or no? Okay. Now the problem is when I'm processing these big inputs, okay, let's say I have 1 lakh sentences in unit 1. Okay. Now when I want to generate the summary, I have to know what is there in the beginning. Okay. So 1 lakh words and when I'm currently 99,999, I should know what is there in what? First word. So problem is when you are back propagation through time, we change the weights. For one example processing, we don't change. But if I once process the entire 10,000 words and if I want to go for second time processing of the 10,000 words again, I change the weights, right? So if 10,000 words weight change ante, what will happen? At the end, that is when I am going from 99,999 to 1, weights right? Weights will be, we take very small random weights, right? As you have observed, 0.01, 0.09, 0.02. 0.09 itself is a very small value which is generated for 99,999. So when I go back to backward propagation for second epoch, what will happen? For the first sentences, the weights would not be there, 0. That is called as vanishing. So when I am back propagating, the weights will gradually what? Decrease and go disappeared. So what will happen? The weights disappear. The previous input would be processed like that without any change. There is no point in I processing the data without weights added to that. Okay. So read that. As the number of hidden layers grow. Why do I grow hidden layers? Because I have my large input. For each hidden layer, one word is processed, right? So if I have more words, what do? I take more number of hidden layers, right? As the hidden layers grow, gradients become what? Very small and the weights will hardly change. The weights will hardly change. So if the weights are not changed, there is no point in processing the inputs without the weights getting changed. So this problem is called as what? Vanishing gradients. Next, similarly, we calculate derivatives, right? Backward propagation of derivatives calculation, based on that again we go for forward propagation. Okay, so when individual derivatives are large, the final derivative also becomes what? Huge. Okay, this is called as exploding. Vanishing ante weights would become to 0. Exploding ante the derivatives of the weights would become too large. This is also a problem. So what are the two problems of RNN? When we process long length sequences where the number of hidden layers are increased. So we have these two problems. What are they? Vanishing gradients and exploding gradients. So andukane we don't use RNN, but we use two different types of RNN architectures which are called as LSTMs and GRUs. Long short-term memories and gated recurrent units, which is the topic for next session. So first today we will see only what is RNN, how RNNs are processed, how RNNs will work with an example. Tomorrow you will see about what? To overcome the disadvantage. First ANN చూసినాం. దాని disadvantages కోసం we have gone for RNN. So we have seen what? RNN disadvantages. To overcome this we'll have next session which would be on LSTM, long short term memory, which is another variant of RNN architectures. Okay, so what are the advantages of RNN? Sequential modeling is done and memory elements are there in RNN. But what are the drawbacks of RNN? Vanishing gradient and long training times. Why are the training times long? More hidden layers? Obviously more training time. Okay, so to overcome these problems we have what? LSTM, long short term memory and gated recurrent units. GRU చదవము, only LSTM we will study. Okay, so what is architecture of RNN? X of t, ht minus 1, apply that to tan h, we generate what? H of t. This was done. So the architecture is little bit changed in LSTM and GRU, which will be discussed in the next sessions. Okay, now when you look into this, look at that. In 1990s, the actual era of AI with advancements have been taken place. And then we have recurrent neural networks, we have LSTMs, GRU, we have the concept of attention, we have dot product attention, another variation of attention. Using these concepts, we have generated what? Transformers. And transformers are the reason why we are using our chat GPTs. Chat GPT is what? Generative pre-trained transformer. Using RNN as base, all these concepts have come into picture. The base architecture is what? RNN. Are you all clear with this? Yes or no? So these are the concepts that we are going to cover in your sessions. RNN is the first one. Prehistoric era is MLDL, we have done. Second is what? RNN, which we are doing today. Next session we will be talking about what? LSTMs. After that, these two different types of attentions for 2 more days. And then finally, the transformer models. Are you all clear with this? Yes or no? Okay. Now we'll start the quiz on RNN theory. ఇప్పుడు ఏం చెప్పామో దాన్ని బట్టి you'll have some theory questions on RNN. So 10 minutes we'll have theory on RNN. Okay, after this you take a break. After the break, we will have a exercise. Open your laptops, log into Tufan 10.11.52.100. So can you see the quiz questions on RNN theory NPS 21/1/2025? RNN works for Google stock price prediction. What is Google stock price prediction? I want to predict the stock price of Google company. Okay. Now, what do you see here? What do you all see here? A graph. What is there on x-axis? What is there on y-axis? On x-axis, I have a graph of 9 days. How many days? 5 days. Okay. And on y-axis, I have the value of the graph, whether it is medium, low or high. Okay. What is that blue line? The prediction of the Google stock price, whether it is high or low on those respective 5 days. Okay. For example, the stock price went up on which day? 4th day. First 3 days, what is minimum? On 4th day, it was too high. After that, is gradually coming low. Okay, this is a simple example. Okay, what do you observe in this figure? In the same graph, I have 2 companies' stock price prediction. One is the blue line, the other company is on red line. So what is the difference that you observe here in these two lines? The blue line is starting from where? Day 0 to day 9, whereas red line, the new company has come up, which is started from day 5. This is variable length. I have two different types of data, and the length of the data is different in two cases. The first data is for 9 days, the second data is only for 5 days, 4 days or 5 days. So even in these cases, your RNN model works efficiently. Okay. Now, what am I supposed to do? Take one input and then predict the output. So what is my output prediction here? What is the stock price for day 10? So how am I predicting the stock price for day 10? Looking at the previous sequential data which was there from day 1 to day 9. Okay. Now what about red line? I want to predict day 10 based on what? Day 5 to day 9. Okay. So for this we use which type of neural networks? RNN. Okay. Now what do you observe in this figure? I have three boxes, three square boxes. What is the first square box? Input. Second square box? Hidden. Third one? So before we give input to hidden layer, what do? We add weights. We multiply inputs with weights and add a bias term. So can you see that in between? So what is the weight that is generated here? 1.8. Why am I using sum? X into W plus B. So I am performing multiplication of input with weights. I am taking a sum term there and I am adding a bias term and giving that to which layer? Hidden layer. Again, that hidden layer in RNN has what? The loop, feedback loop. Can you observe that feedback loop? Yes or no? After that, the output of the hidden layer will again have some weights generated, bias, and then I finally give it to the final output. Are you all clear with this diagram? So we take the inputs, multiply the inputs with weights, add that with bias term, give it to hidden layer, whereas in hidden layer we'll have a feedback that would be processed, and then from hidden layer we'll again calculate weights and biases and then give it to output layer. So what is the new thing here? Only the feedback thing. Other than that, weights, bias, activation functions, input layer, hidden layer, neural network, everything is same like what? Everything is same like ANN. Okay. The only difference is what? The feedback loop. Okay. Now when I talk about the stock price prediction, okay, so I have three ranges, 0, 0.5, 0.1. Okay. So let's take 0, 0.5 and 1. Okay. So what would be the input? If suppose I am processing day 1 currently. What is the input of day 1? It is 0. What is the input of day 2? It is 0.1 or 0.2. What is the input of day 3? It is around 0.2 or 3. 4 is 1. 5 is 0.4, something like that. So when you are in current state, you will give that input to the input value. For example, here simply I have taken it as what? Let's consider it as day 4. So what is the input? Sorry, day 5, which is around 0.5. For that reason I have taken it as 0.5. And then I multiply that with weights. How are we generating these weights? Random, using rand function, random.randn. Exercise. So same like randomly I generated the weight which is 1.8. I'll multiply that and process the output. Is it clear? So what is the output there? It is 1. It is 1 because the arrow mark shows it is increasing. After day 5 it is increasing. So day 5 I have taken it as 0.5 as input. As the arrow mark shows increasing, so day 6 would be what? 1. So the machine is predicting it as what? The output to be 1 as it shows the arrow mark which is increasing. This is just for understanding. We reference kosam with real time data in kaadu. Okay. Okay. So on day 10, what you can see? Look at the output on day 10. It is 1.0. Why? Previously on day 9 it was 0.7. On day 8 it was 0.6 or something. So 0.6 నుంచి 0.75 వచ్చిందంటే next day also it would be increased. So if I take 0.75 as input, what is the predicted output? 1 because for the past 3 days it is gradually increasing. Is that clear? So this is how your RNN works by taking the input and producing the output. Okay. Now you can see 4 graphs there, right? What is the first graph? I have 3 values represented on x-axis. What are those 3 values? Yesterday, today and tomorrow. In the first graph, if today's value is low, yesterday's value is low, what would be tomorrow's value? Low. In the second graph, if today's value is slightly increased than yesterday, so what would be tomorrow's value? More increased. In third graph, if yesterday's value is decreased compared to previous value, so tomorrow's value would be gradually decreased. Fourth, last case, if today's values and yesterday's values are high, tomorrow's value also would be what? High. This is how the machine will predict. Based on what? Today's value, previous value. Today's value is x of t. Yesterday's value is ht minus 1. Looking at these two, it will produce the h of t, that is the next output. Okay. Now look at this. What is happening here? I'll take today's value, give it to weights, biases, feedback loop, and then calculate my next output. Okay. Because the recurrent neural network has what? Feedback loop. It will be able to read yesterday's data, today's data, and give what? Tomorrow's data. Okay. So similar like how we do calculations there, same. W plus D, apply activation function of Wx plus D, all those calculations happen, and then it will give you the result. Okay. Now look at this point and understand this point very carefully. If I take yesterday's value, my output will be what? Today's output. For the current state, if I take today's input, my output would be what? Today's output only, because initially I don't have previous state. First value this, see, day 0. When I take day 0, the output would be for day 0 only, but not the previous day. So do I need that output? When I take today's value, do I need today's output? No, because for predicting tomorrow, I need today's input, previous output. So that is the reason we take it like this. Look at this. So what do you see here? I have 2 blocks. In the first block, the first day input would be processed. Understand this very carefully. In the first block, don't look at the second one, masked one chudakandi. Okay. In the first block, in the input, I take today's input, I pass it to hidden layers, I get some output. But do I need that output? No. But what will I do is, that first output, whatever I get, I take it as feedback, that is ht minus 1 from the hidden layer. I take the next input, which will be what? That today will become yesterday. Yes or no? Ardhamautunda leda? Listen to me. First I have input. That input is day 0. That input is what? Day 0. The output would be what? Day 0's output. Okay. But I don't need day 0's output. I want to predict. So, I take the next layer where our first hidden layer would be ht minus 1. The second would be day 1, which will be x of t. The second input is what? X of t. The first hidden state output would be ht minus 1. So that ht minus 1 would be yesterday. The current input would be x of t. Based on this, I'll generate what? That is your final predicted output. That is, we will take 2 different inputs here. 2 inputs is what? Yesterday's input, today's input. Got it? And then I'll generate 2 outputs. What are those 2 outputs? Yesterday's output, today's output. But do I need yesterday's output? Because I've already calculated today's. So based on that only I've calculated today's. So based on today's, I'll calculate what? Tomorrow's output. So I'll consider this way. So first I take yesterday, I'll get value for today. Now I'll take value for today, and then I'll get value for what? Look at this diagram. This is clear. So I'll take what? Today's value, take it as input. Along with this input, take what? Yesterday's value as hidden state, and then try to predict what? The final output. This is the complete block diagram. Is that clear? So what is input? X of t. What is the previous hidden state input? ht minus 1. What is the output that you are generating? H of t. Is that clear? So this is how your sequences would be processed. So predicting value for tomorrow. Based on what? Today's input and yesterday's input, which I am getting from what? Previous hidden state. Is that clear, everybody? Okay. Suppose if I want to predict, what am I doing here? I am predicting tomorrow's output based on yesterday and today. That is 2 states. If I want to predict tomorrow's output based on 3 days, so what will I do? I'll write what? 3 layers. I'll take what? 3 layers. Where first layer would be day before yesterday, second layer would be yesterday, third layer would be today, the output of today would be what? Tomorrow. Is that clear everybody? Yes or no? So first is day before yesterday is the input. What output would I get? When I take day before yesterday's input, the output would be yesterday. When I take yesterday as input, the output would be today. When I take today as input, the output would be tomorrow. So do I need only one output or all these three outputs? One output only at the end. I want to predict what? Tomorrow's result. Based on what? Day before yesterday, yesterday and today. Day before yesterday is given to yesterday in the hidden state. Yesterday from hidden state I am taking it to today. So today with the day before yesterday and yesterday's hidden state I am calculating what? Tomorrow. Is that clear everybody? So what are the inputs? Day before yesterday, yesterday and today. And what is the final prediction? Tomorrow. Is that clear everybody? Okay. So now look at the weights and biases. Am I changing the weights and biases? No. Why? Because yesterday's input is different, today's input will be different, tomorrow's output also would be different. So I am not considering changing weights here. So this is called as shade parameters which is there in RNNs. Clear everybody? Yes or no? Regardless of how many times we unroll a recurrent. What do you mean by unrolling? 3 times I am unrolling here. Okay. Because I have to consider what? 3 days feedback and take the next prediction. So despite of how many times you unroll a recurrent neural network, the weights and biases shared across the network would be same. Am I changing any weights and biases here? No. So the computations would be gradually reduced. Is that clear? So this is what you're going to do tomorrow in the lab. Okay. So today I'll explain you another exercise. How do you do coding for RNN? Not from scratch. We will use a library called as PyTorch library. What is that? We'll use one library called PyTorch library. If I can't sit and explain PyTorch library, but as I told you, the sessions on PyTorch is recorded already. Okay. So I'll share Rupa Madam the link, the KMIT Vista link where PyTorch sessions are recorded. It's only for half an hour or 45 minutes. You can just listen to PyTorch library. You'll understand what is that. Today we'll start working on what? If time permits, I would have told you, but I want to explain the code in detail. Okay. So look at that PyTorch library for 40 minutes. You'll understand what is that. Okay. I'll give you some basics, but then yeah. Okay. So let's switch to the exercise. Yeah. What is the exercise that we are working on? Time series forecasting on using what? RNN. What do you mean by time series forecasting? Same like what we have seen, Google stock price prediction. I'm forecasting the future based on the previous time series data. Is that clear? Now, when we work on IoT devices, what are IoT devices? Internet of Things. Sensors nunchi data continuously collect cheskoni, we will predict, right? Yes or no? So, are we getting the data? See, is it okay if I predict something from the sensor data which I took 10 years back? Current data which I am taking from the sensors for today, based on that I predict. Same like ECG signal. What is ECG signal? Electrocardiogram signal. Okay. So I want to predict whether a person has heart disease or not based on the current report which has sequence in signal. Right? Yes or no? Okay. So we'll do that exercise today. Okay. So build a RNN model using what? Using PyTorch to predict future values of a simulated ECG signal. So time series data can be anything. Okay, ECG signal iskondi lepote oka stock price prediction, whether edaina iskondi, it is fine. Okay, so today I have taken what? A random ECG signal. Okay, I didn't take any data set here. I want to create my own ECG signal. Is it clear? So I'll explain you how do we create that ECG signal and how do I treat that as ECG and how do I develop a RNN model for PyTorch. Okay. Now, before we actually go, let me give you some brush up or important topics that you have to understand when we talk about PyTorch. Okay. As I told you, for working on with AI, we need some libraries. First, we have seen NumPy. What is NumPy? Numerical Python, which we use for mathematical operations, calculations in the code, right? So yesterday in the lab, we have used Python, right? NumPy, right? Why? Because for forward propagation, NP dot product of that. Okay. For many cases where you want mathematical calculations, we use NumPy. We also use pandas for reading the data set, for working on with the data set, for data pre-processing. We require what? Pandas. Matplotlib and Seaborn for visualization. Tarata sklearn for pre-processing operations, train test splitting, model selection. All the machine learning, classic machine learning algorithms are available as a code in which library? sklearn. Okay. TensorFlow kuda vaadam ninna. TensorFlow for what? Sequential model, dense layers. Okay, for developing ANN not from scratch. Module wise ANN development can be done by using what? TensorFlow. Atlani, same like TensorFlow, we have this another advanced library with so many inbuilt functions, which is PyTorch. Most important library of AI, where so many functions are inbuilt. మనం అక్కడ సీక్వెన్షియల్ తీసుకున్నాం కదా, ఇక్కడ PyTorchలో NN అని ఉంటుంది. PyTorchలో what? NN. Is it clear? Same like sequential model there, we have this model called NN, neural network. We use this PyTorch mostly for sequential data operations. For RNN development, we use this PyTorch. Is it clear, everybody? Okay. So, PyTorch ఎందుకు వాడుతున్నాం ఇక్కడ? Good news for you. We are not doing that forward, backward, everything point by point. We will just use the words what? Forward, backward and loss calculation. From where? This module which is called as what? NN. Module called what? NN, which I am importing from where? PyTorch. Here the main agenda, అడగొచ్చు madam, why not RNN from scratch? Here the main agenda for you to understand x of t, ht minus 1, h of t. This is important concept. Understanding about how forward is done, how loss is calculated or back. Now you have that idea. So let's not burden ourselves with the same concepts again. We'll use NN module. We will use RNN from scratch. RNN from scratch in the sense, how the sequence is taken, how the sequence is generated. Adi scratch nunchi chusi. For forward, backward and all this, we will use what? NN module from PyTorch. Are you all clear? Sequence generation, RNN sequence processing will do from scratch. But forward propagation, backward propagation and all that, for which we will use what? NN module. Are you all clear with what am I going to do today? Yes. Okay, now read the first step. First, we have to prepare the data. Okay, so tomorrow Google Talk Prize, we will give you a data set. Ikkada I am creating a data because see, you should know different ways in which you read the data. Ikkada data etla create cheyalno I'll show you. Tomorrow already existing data, how to take it and how to pre-process it, you should know. So we'll do it in two ways. Okay, so today I am not taking any data set, but I am creating my own data. So I want to prepare my data. Okay, second step, RNN model. How am I developing RNN model? From using pytorch.nn, I am developing my RNN model. Okay, and then I want to train the model. How do I train the model? I first calculate loss. I change the weights by using what? Optimize. See, chala mandi ikkada confuse avutaru. Change the weights ante madam you told we will not change the weights. Okay, listen to me. I have a paragraph with 3 sentences. I'll process this paragraph of 3 sentences of different length one time. Appudu weights change cheyam. After completion of loss, when I want, if my loss is too high, when I want to process these 3 paragraphs again, appudu I'll change the weights. Are you getting my point? I have 3 paragraphs, 3 paragraphs lo 3 different sentences. Hence I take 3 layered RNN, like choosara, tomorrow is based on day before yesterday, 3 blocks. So those 3 blocks, because I have 3 inputs. If suppose my first sentence says I am ASHA. So for processing this first sequence, I have 3 blocks. I am ASHA. For second sentence, I say I am teaching in auditorium. 5. I am teaching in auditorium. Ikkada weights change cheyanu. Okay. The students are good today in the class. Here also I will not change the weights. First I will process these 3 sentences. For these 3 sentences I am not changing the weights. I will process these 3, generate the output. I will get the loss. When the loss is high, I have to, this is one epoch. I want to train the model again for the second epoch. Appudu I will change the weights. Got it clear? So madam, weights change cheyappudu naaku ardham kavatledu. This is the story. Is it clear, everybody? We won't change the weights for the first processing of the input, even if it is of variable length. For the first epoch, we won't change the weight. For the second epoch, we change the weight. For third epochs, again we change the weights. Is it clear? Okay. So we do the training by using MSC loss as a loss function and Adam as the optimum. Last time gradient descent వాడారు కదా, ఈసారి మనం గ్రేడియంట్ డిసెంట్ అంటే అన్ని DZ2, DW2, అన్నీ చేసినాం. ఇక్కడ యూజింగ్ PyTorch అంటే ఓన్లీ గ్రేడియంట్ డిసెంట్ అని రాస్తాం, అంతే, పేరు ఒకటి రాస్తాం. సో వీ విల్ యూజ్ అనదర్ ఆప్టిమైజర్. లెట్స్ సే వీ విల్ యూజ్ వాట్? Adam. సో అందుకనే టు ఇంట్రొడ్యూస్ యూ టు న్యూ ఆప్టిమైజర్ ఐవ్ టేకెన్ Adam టుడే ఇన్ ద క్లాస్. ఇస్ ఇట్ క్లియర్, ఎవ్రీబడి? గ్రేడియంట్ డిసెంట్ కూడా వాడుకోండి, మీ ఇష్టం. ఓకే. అండ్ దెన్ I want to train the model for how many epochs? 50 epochs. Okay? And I don't want to print all the laws for 50 epochs. I want to print the laws for every 10 epochs. And 10 epochs, what is the loss? After 20, what is the loss? After 30, what is the loss? After 40 and 50, what is the loss? Okay? So train the model for 50 epochs and monitor the loss for every 10 epochs. And then finally make predictions using model.evaluate. Is that clear, everybody? So what are we going to do? This is a very interesting exercise. What are we going to do, guys? Prepare the data, develop the RNN model, train the model, evaluate the model. Simple 4 steps. Is it clear? But developing the data generation is different because in RNN feedback only on first step you have to focus. 2, 3, 4 would be easy. Difficult. I'll try to make it as easy as possible. Try to understand it clearly. Concentration 100% you will not understand. What is step 1? Okay, so what libraries am I importing? First, I want to import NumPy. For mathematical calculations, weights calculations, I want to import what? NumPy. I'll also import what? Pandas. And then I'll also import what? PyTorch. PyTorch, which module am I importing? Torch. PyTorch is the name, Python torch. Can module would be torch and the name. Torch.nn module I am importing. NN under neural network development. Is it clear? Next I am using what? Optim. And optimizers. I am not defining DZ2, DW2. I am just writing Adam. From where am I uploading that Adam? From torch.optim. So what are the new things, 2 new things that I am uploading, guys? Torch.nn, torch.optim. And then matplotlib for what? Visualization. You know about standard scalar, right? Features. Okay. So I have min-max scalar, minimum value, maximum value scaling. So for that I use what? Min-max scalar. Okay. For data pre-processing. Okay. So what libraries am I importing? NumPy as NP, Pandas as PD. Import torch. And again from torch I am importing what? Torch.nn as NN. I am simply writing it as NN. From torch.optim I am just writing it as what? Optim. And then matplotlib.pyplot as PLT. From sklearn.preprocessing I am using what? Last time standard scalar order. That is one type of scaling. The second type of scaling is what? Min-max scaling. Just read what is that min-max scaling. We will not focus on that now. Is that clear, everybody? So standard scaling is one type of scaling. Min-max scalar is another type of scaling. Okay. Next, simulate and process. Simulate and pre-process ECG data. Okay. Now listen to what I am doing. ECG data etluntadi? Sine wave. Very perfect answer. Sine wave la untadi. Equal, proper, beautiful sine wave untada ECG. High, sometimes low. So listen to this. How I create a ECG signal is, first I generate a sine wave and add some noise to it. Add some noise. Obviously noise add chese emaitadi? A beautiful sine wave kasta worst sine wave tayaraytadi. So that I am treating is as what? ECG signal. Ardhamayipoyinda? Yes or no? What am I doing, guys? I am just taking a sine wave. I'll generate a sine wave using NumPy. np.sine and sine wave vachestadi. Okay? Our range ivvali. I'll give some range. So I want to generate 1000 samples. How many samples? 1000 samples. Is it clear, everybody? Yes or no? Did you understand this first? What am I trying to do? I am trying to generate a sine wave. How am I generating the sine wave? I generate sine wave using NumPy, that is using the function np.sin. I'll generate a sine wave. So the sine wave will be actually beautifully equally represented. But what do I want to do when I talk about ECG data? I want noisy sine wave. So I add some noise to that. This is first point. Second point, I want to generate 1000 samples. So using the function line spacing, I'll give 0 to 1000 with space of 100. What do you mean by space of 100? Interval. 0 to 1000 is the range. With intervals what? 100 I want to generate a sine wave. Now is your data ready? Yes or no? Is your data ready? What is the data? ECG wave which is represented from 0 to 1000 with sequence what? With interval what? 100. అంటే మీ గ్రాఫ్ లో ఎట్లా కనిపిస్తుంది 0, 100, 200, 300, 400, 500, 600, 700, 800, 900 and 1000. This is how your data will appear. Are you all clear with this? Yes. With some noise added to that. Okay. Now, what do I want to do? Read these 1000 samples and generate the data for what? The next sample. Okay. But RNN has a problem. What is that problem? Long range dependencies. Here I have 1000 length. So I don't want to take 1000 length data as it is. So what I do here is, I divide this 1000 data into 50 data. 50 different samples. What am I doing? I divide this 1000 data into 50 samples because my RNN will not process all the 1000 samples together. So I'll divide this 1000 into what? 50 sequences. So each sequence would be of length how much? 20. 1000 undi 50. 50 into 20 is what? 50 into 20 is what? 1000. Is it clear everybody? So now tell me how many samples are there? N is equal to what? Total number of samples? 1000. Total number of samples is what? 1000. Total number of sequences? 50. One sequence of length how much? Got it? Let me repeat. How many samples? 1000. 1000 samples are divided into how many sequences? 50. How many samples does each sequence have? Are you all clear with this? Yes or no? Now listen. When I take first sequence as input, so what will be the sequence? 1 to 1000 lo 1 to 20 would be my input. So what will be my prediction? 21st element would be my prediction. Seeing these first 20 samples, I want to predict what? The 21st sequence. Are you all clear with this? Yes or no? So how many bits output I am taking here? 1, which is what? 21st bit. అర్థమవుతుందా లేదా? Okay, let me repeat. How many samples in the sequence? So how many samples in the data? 1000. These 1000 samples are divided into how many sequences? 50. Each sequence is of length how much? 20. So when I take about my first sequence, what would be first sequence? 1 to 20 would be my first sequence. What is the output? RNN and enti. Seeing the first 20 data, you have to predict what? The next data, which is 21. Okay. Now second sequence would be 21. I mean, under the output, that's okay. I'm just dividing the data. So for the first sequence, input would be what? 1 to 20. Output would be 21. For the second sequence, input would be what? 21 to 40. Output would be 41. For the third sequence, input would be 41 to 60. The output would be 61. Hence, atla till what? All the 50 sequences. Idi cheyali. Only this coding is important. Idi vacheste remaining everything you all know about it. You have to understand this. What is N? 1000. Sequences? 50. Length of sequences? 20. Output size? So what is the input that I am taking here? Sequence as input, not all the samples. Because all the samples cannot be processed in ANN. So what is the input that I am taking? A sequence. What is the length of the input here? 20. What is the length of the output? 1. Ardhamainda andarki? Yes or no? Okay. Shall we go to the code now? Okay. First I am creating a ECG signal. I am taking a variable called time underscore steps. Okay. What is the input variable here? Time underscore steps. And I write np.linspace 0, 100, 1000. What do you mean by this? Create a sequence or create the samples from where? 0 to 100 with range what? Sorry, 0 to 1000 samples with range 100. So this is how I created a simple, not sine wave, a simple samples. I am generating the samples. Now using these samples, I want to generate a sine wave and then add what to it? Noise. So observe the second line. I am calling the input as ECG signal. What is the input called? ECG signal. And in that I am taking np dot create the sine wave of what? The time steps generated. First I am generating the time steps and write np dot create the sine wave for what? The time steps. Time steps and 0 to 1000 samples with 100 range. Okay. plus I am not just creating a sine wave. ECG signal is what? Sine wave with some noise added. So how am I adding that noise? NP dot random dot normal. Okay, NP dot normal, random dot normal. So I am giving some attributes, that is scale is equal to 0.1. Don't add too much noise which goes beyond the original input. Adding noise beyond the original input is not preferred. So I am adding a noise with some scale, and I am writing size is equal to what? Length of time steps. So how much noise do you want to add to the entire signal? I want to add noise to the entire signal. So length of the time steps, the entire 0 to 1000, I want to add noise. Are you all clear with these two lines? Yes or no? So what did I do now? I have taken a range of values from 0 to 1000 with range 100. I have created a sine wave on these 0 to 1000 range, and I have added some random noise to it. Now my input is ready. But do you understand anything from that sine wave? No. So I want to convert this into data frame. Data frame and you must be able to observe the values of the sine wave, because I want to predict numerical data. I am not giving the sine wave as image input. I want to give what? Numerical data, like Google stock price prediction, we have seen medium, low, 0.5, 0.1. I want to create the values from the graph. Okay. So for which I create a data frame. I write df is equal to, using pandas, pd dot data frame on what? On that ECG signal. Okay, create a data frame on the ECG signal and print 5 rows. Now this is the values printed from the sine wave with noise added. Are you all clear with this? So what did I do here? What did I do? I have created an ECG signal using sine wave, and I have converted that ECG signal into what? Data frame. Now I have sequence of values. I have just printed 5 rows using df.head. Okay. If you want to print all the 1000 also, you can do it. Only just give df. What will happen? All the 1000 samples would be printed. Okay. Now I want to prepare the data for. What do you mean by preparing the data? Dividing those 1000 samples into 50 sequences, each of length 20. Not just converting. Here, first sequence would be processed for I in 50. Why 50 epochs? Because I have 50 sequences. So for the first sequence, I would be what? 1 to 20. For the second sequence, I would be what? 21 to 40. For the third sequence, I would be what? 41 to 60. Is that clear? Now, when I take, I have 1000 samples. For the first time, when I take I is equal to 20, what will happen? The 1000 becomes 980. The input size would be 20. The output size would be 1. That 1000 lo 20 pieces. For the second cycle, what happens? That 1000 becomes 940, 20 and 1. Okay, but I am not bothered. I only want one sequence at a time. Is that clear, everybody? So I have 1000 samples. When I take out those 20 samples as input, n would become what? 980. Is that clear, everybody? Okay. Let's see how do I do that. Okay. Converting the data into sequences. Okay. I'll explain you step by step very clearly. Okay. Now listen to this. I am taking the sequence length. I have to give what is the length of the sequence that I want. Not number of sequences. 50 is what? Number of sequences. Sequence length is what? 20. That is, how many samples am I taking in one sequence? Okay. So first I have to initialize what? First I have to initialize what? Sequence length, which is what? 20. After that I want to create the sequences. How am I creating the sequences? I'll take the data. Data and 1000 samples. Okay. I want to take the data. And out of these 1000 samples, each sequence should be of length what? 20. So I pass what parameters? The total data and sequence length as parameters. So how many sequences will be generated? 50. 1000 unnai, 20 sequences kavali ante, what would be the output of this? 50. Is it clear, everybody? Now, sequence is equal to empty, target is equal to empty. Enduku ante, first time what would be the sequence? 0 to 20. Target would be what? 21st. Second time what will happen? The sequence will have 21 to 40, target would be 41. That is the reason initially I am putting the list as what? Empty. From that I will read it, append it to this. Is that clear, everybody? So what is sequences? Input, which are 20 bits. What is target? The output, which would be 1 bit. Are you all clear with this? Yes or no? So what am I doing here? I am creating a variable called sequence length and saying that out of those 1000 samples, each sequence should have how many length? 20 bit length. So sequences is nothing but the sequence that I generate. Target is nothing but 1 bit value. Okay. After I do this, what I do is, now I'll put this into loop. What is this loop for? For generating those 50 sequences. అర్థమవుతుందా లేదా? 1020. ఈ 1000 లోంచి 20 డివైడ్ చేసి అట్లా ఎన్నిసార్లు చేయాలి? 50 times. Okay. Now we'll see what will happen. For I in range, and let's say first sequence, for I1 in range of what? Length of data minus sequence length. What is length of data? 1000 minus 20. 1000 minus 20, which would be what? 980. Until now the sequence is what? 980 because you have taken one sequence out of it. ఇది మైనస్ చేయలేదు అనుకో, 1000 minus 20 మళ్ళీ 1000 పెడితే మళ్ళీ ఫస్ట్ సీక్వెన్సే వస్తుంది. ఎవ్రీ టైమ్ యూ డూ ఇట్, వాట్ విల్ హ్యాపెన్? ఫర్ 50 times you'll get 1 to 20, 1 to 20, 1 to 20, the output would be always 21. I don't want this. Once I take the first sequence, the original sample should become what? 980. Second time when I take the second sequence, the sample should become what? 960 and so on. So for I in range of what? Length of data minus sequence length, which is 20. That is 1000 minus 20 is what I am doing here. Okay. Now I am taking another variable called sequence. Okay. Sequence is equal to data of ekkadi nunchi ekkadi varaki 1 to 20. 1 to 20. I is to I plus sequence length. 0 to 20. Okay. 0 to 19 or whatever it is. Okay. I is equal to I plus sequence length. So the first 10-20 samples would be taken. Target is what? 20 first element. So I plus sequence length. Are you all clear? What is I? 1. What is the sequence? 1 to 20. What is the target? 20 first. So I plus sequence of length. Are you all clear with this? Yes or no? అర్థమైనా లేదా? సో ఇప్పుడు సీక్వెన్స్లో ఏముంది? SEQలో ఏముంది? 1 to 20 samples. టార్గెట్లో ఏముంది? 21st. So where should I append this? Sequences and target. Empty list ఉంది కదా, దీంట్లో I have to append. So I write sequences dot append of SEQ, targets dot append of targets. Are you all clear with this? So what did I do now? First I have generated 0 to 1000 with range 100. I have created a sine wave by using np.sine, adding some noise to it. And then I've converted that into data frame. This was step 2. Step 1 was importing libraries. Step 2 was what? Creating a data that is a simple ECG signal and converting it into data frame. In third step, what am I doing? I'm converting this data into sequences. I'm converting this data into sequences such that each sequence of 20 length would be processed by the RNN model. Okay. Now, after I do this, I return what? I want to return sequences and I want to return target. Okay. Now, once I am done with this, let me calculate the shapes. Okay. Now, in PyTorch, listen to this. Before I convert it to shape, in PyTorch, when you are using this PyTorch module, the input data that you have 20 sequence target idundi undi kada, they should be converted to tensors. Tensors ante the data representation in a matrix form. When you use PyTorch, you have to give the input data as tensors. So we have to convert our sequences, our targets into tensors. Okay. So how do we convert? X is equal to, now I won't take sequences and I won't take targets. X is sequences, that is input. Y is the output, which is target. Is it clear? Now for RNN, for PyTorch, what am I creating? X and Y. What is X? That sequence. What is Y? That target. Are you clear with this? Okay. So X is equal to torch.tensor. Using PyTorch, please convert that into tensors. What am I passing here? Sequences. In Y, what am I passing? Target. Did you understand what are tensors? Your NN module will take only tensors as input and output. Hence, you have to convert your other variables to tensors which are in matrix form. Okay. Now, there is another this thing here. When you are converting it into tensors, you have to add one extra dimension. Last oka dimension okate extra add cheyali. For that, I go for unsqueeze method. Last ki kanpistunda? Unsqueeze of -1. That last bit would be what? An extra dimension added to the tensor. Is it clear? So I am just putting what? Dot unsqueeze of -1, both for input and output. Now what is your input, guys? X. Now what is your output?
Y.
Did you all understand till this? Okay, I'll repeat it. ఇది ఒక్కటి అర్థమైతే RNN అయిపోతుంది. Okay. So first I'm taking sequence length is equal to 20. I'm creating a sequence length with respect to what? Data and the length of the sequence. I'm creating an empty input which is called sequences. I'm creating an empty output list which is called target. Here I'm defining a loop wherein I write for I is equal to range of what? All the data with respect to sequence length. Take one data at a time which is called sequence. Create one output which is the next element which is what? Target. Okay. I'm creating the tensors here and I want to print the shapes. I want to print the shapes of what? X shape and Y shape. Now tell me what is the size of X shape? 20. X is what? The sequence is 20. Y shape is what? 1. Y is the output, which is the target, which is what? 1. Okay. So what is the X shape, guys? N minus 20 comma 20 comma 1. What is this N? 1000 minus 20. 1000 minus 20 is the first sequence, comma 20 samples in that, comma 1 output. Look at the output Y. What do I have in Y? N minus 20 comma 1. The N minus 20 samples lo nunchi my output is what? 1. Is it clear? Look at the torch size. What is 980? I have taken 1000 samples out of which I have extracted 20. So the total N is what? 980. The input is what? 20 comma 1. Whereas when I talk about output, out of 980 samples, the output is what? 1. Is it clear, everybody? Okay. Now we'll have to define RNN model. Now I have to define what? RNN model. So am I writing forward, backward and all that? So ఇది చాలా easy ఇక్కడ నుంచి. Okay. So I'm taking a class called RNN model. I'm taking a class called what? RNN model, in which I am passing the variable what? NN dot module. From where did I take NN? PyTorch. NN dot module. Define init function. This is object oriented Python programming. Okay. Parent class, child class, because n number of times I want to inherit the parent class which is NN module. So I take init function there. Okay. And then pass input size, hidden size, number of layers. Number of layers is not mandate. Okay. So what is the input size here?
1.
1. And okay sequence I want to process. Hidden size 64. Reason being, listen, I have 50 samples, right? I can't take hidden size is equal to 50. One sample will take one hidden layer. So generally the hidden layers would be of size 32, 64, 128, 256, 512. Here any samples unnai naku? 50. So how many hidden layers do I have to take? 64. I can't take 32, I can't take 125 and waste my time. So how many hidden layers am I taking? 64. Where each hidden layer will take what?
Term that we use for inheriting the parent class. Okay. Self.rnn, nn.rnn. What is this nn again? The module. .rnn is what? The model that I have developed. Okay. Input size, hidden size, number of layers that I want to add, and path size. After that, I do forward propagation. How am I doing forward propagation? Only using the function forward self of what? X. X and then what? The input that I am taking. Okay. RNN.out, self.rnn of X, and then finally I am printing my output. After you take the class, you have to instantiate the model by using model is equal to RNN model, print that particular. Here I have instantiated or called what? RNN model. Now I'll start training. Okay. Now look at this. What is the
Input to the model? N minus 20 comma 20 comma 1. What would be the output of the RNN layer? Total samples are processed with hidden layers how many? 64. What would be the output of the fully connected layer? 1 bit. Okay. Now let's see training. Okay. This is very simple now. Look at that. I am taking criterion is equal to which loss do I use here? Why did I take MSC here? Because the data has continuous values. So it is a regression problem. Hence I have taken which loss function? MSC. So I have taken a variable called criterion in which I write NN dot MSC loss. And optimizer, which optimizer did I tell you in the beginning? Adam. So optim dot Adam. So inside that Adam, I will pass the parameters which is learning rate. After learning rate 0.01, the same thing here. Okay. Now look at the training loop. How many epochs do I have to run the code for? 50. For epochs is equal to 50. For epochs in range of epochs, model dot train, the train model already we have done, right? Now look at that. Outputs is equal to model of X. What is output? By processing the inputs which are there in X, loss is equal to criterion of output, loss dot backward optimal. That is, I am doing forward propagation, loss calculation, backward propagation all together. Do you see weight into the X into W plus D or calculating derivatives, activation functions defining from scratch? Not all that, because I am using which module? NN directly from PyTorch. Are you all clear with this? Yes or no? Okay, in the training loop, what am I doing? For I in range of epochs, model dot train, I am passing 0 grad. Acha, let me explain about 0 grad. Here we are not changing the weights for the same sequence, right? For different sequence, for also we don't change. After one epoch, we want to change, right? So on the can we put that as 0 grad or no grad. And the gradients will not be changed every time you take the different input. Is it clear, everybody? The weights and bias are same. Hence I take what? Optimizer dot 0 grad. Is it clear? So I do this, and then I don't want to print all the epochs. I want to print the epochs after 10 samples. 50 epochs, after 10 epochs I want to print the loss. Hence I give, if epoch plus 1 divided by 20, that is equal to 0, I want to print all the epochs. Okay. So this is how you will get the, now I want to evaluate the model. How do I evaluate the model? Model dot eval. Already X undi, Y vachesindi, now I want to evaluate. Okay. Evaluate is nothing but now look at that. Here I take no grad. No grad and don't calculate the gradients. Akkada 0 grad, don't change. Here no grad is don't define the derivatives of the gradients. Okay. So torch dot no grad. What is the input here? The test input. That is the second that I want to take. Okay. Akkada unsqueeze chesam kada adding one element. Ikkada delete cheyali kada element. So అందుకని I again go for unsqueeze of 0. Akkada unsqueeze of -1, that is adding one extra dimension. Here I am removing that extra dimension. Otherwise the length of the sequence would be 21. So there I am adding a dimension in the tensors. Here I will remove that by using unsqueeze of 0. గుర్తుపెట్టుకోండి, అక్కడ unsqueeze of -1, ఇక్కడ unsqueeze of -1 కాదు. If you put -1, what will happen? Another dimension would be added, the sequence length would be 22. Okay, I am adding the dimension. Here I am removing the dimensions. So prediction I am putting it as empty. After that, once I start testing the model, I'll add that predictions there. Okay, so for I in range of 50, process all the 50 sequences, predict it already from model test. Test sequence is the input. For that, you please predict the output and append that output to the predictions part and then print them. Is that clear? Yes or no? So this is how we evaluate the model. So what did we do today? Understood the theoretical concepts of RNN, and then we have seen how to do Google stock price prediction, which we are going to do tomorrow. Today we have seen on time series forecasting. Okay, so before you go, I'll just scroll down to the steps. You can just have a quick glance.